Hi everyone, today I'll show you how to do problem number 12 from the Unit 1 problem set. So problem 12 states 4-point charges are at the corners of a square as shown at the right. If Q is equal to 0.1 microcoulombs and A is equal to 5 centimeters, A, what is the net force on the plus 2 charge? B, what is the E field at the location of the plus 2 charge if the plus 2 charge is removed from its position? And C, what is the E field at the center of the square? Okay, so to do part A. So here you'll see that I've drawn my diagram just as the book has it, except I have also labeled each of the particles as 1, 2, 3, 4, just for convenience as I do this demonstration. So, problem A, to find the net force, we're going to have to find the forces in the x and y components separately. So here I'm going to draw in my forces in the x direction, or all my forces acting on particle 3, which is going to be a downwards force from particle 1 acting on 3, diagonally an attractive force from particle 2 acting on 3, and a horizontal force from particle 4 acting on 3. Okay, so now to find the forces in the x direction, we are not going to use the vertical force pointing downwards because it has no horizontal component. Therefore, we're just going to use the force of 2 on 3 plus the force from 4 on 3. And we're going to say this way is the positive x direction. Okay, so force on 2 and 3. So that is equal to K, particle 2's force, or charge, which is Q. I'm using the absolute value here. And then the red particle, particle 3. The distance between the two is A root 2, since it's a diagonal of a square. Then, to find the horizontal component, we're taking cosine 45. And then we're going to add that to the force of the horizontal one, which is 2Q times 2Q. Again, I'm using absolute values of those charges. Simplify that, and we would get now I'm going to put this all into calculator, and you should get 0.169 newtons, and that is the force in the x direction. Okay, so save that number. We're going to use it again. And now to find the force in the y direction, we're going to do the same thing, and we're just going to sum up all of our forces. So the forces here again is this vertical downwards force of 1 on 3, horizontal of 4 on 3, and the diagonal of force 2 on 3. Therefore, we know that the force 4 and 3 only has a horizontal component, so therefore we don't care about it. We're just going to use the other two forces. We're going to say this way is positive y. Therefore, we're going to say we're only going to use force of 2 on 3 minus the force 1 and 3, because force of 1 on 3 is pointing downwards. So doing this one, we get charge of particle 2 is Q, again using absolute value. Particle 3 is 2Q. Distance between them is, again, this is a square, so it's A root 2. We're going to square that because that's a formula of the force. Now, force 1, 3 is, again, Q, 2Q, using absolute value, of course, A squared. And over here, I forgot to say this is sine 45 degrees, since that's the angle right here. That will get you your vertical component of force 2, 3. So simplifying this, we get so now we are going to put this, or plug in our numbers. So I'm going to start erasing this stuff. Plugging in our numbers, I'm going to go back up here. And I'm going to put in plugging that all into your calculator, you should get negative 0.047 newtons, and that is the force in the y direction. Using that information, we now know that in vector form, our net force is equal to 0.169 comma negative 0.047 newtons. Therefore, to find the magnitude of that force, we're going to use the Pythagorean theorem, 0.169 squared plus 0.047 squared, and that will get you the answer of 0.18 newtons. To find the direction of that force, we can say tangent theta is equal to Fy over Fx. That'll get you your answer of negative 15.5 degrees. And that is the answer to part A. Okay, so for part B, it asks, what's the E field of the location of the +2 charge if that charge is removed? So to do this one, we know from our previous problem that our net force is equal to 0.18 newtons. And then we also know that the formula F net is equal to E times Q, or where Q is the charge, and in this case the charge is 2Q, which is the charge of the particle we removed. Okay, so to find E, we're going to have F net over 2Q. Our F net, as found in the previous part, was 0.18 newtons over 2Q is given 0.1 times 10 to the negative 6 coulombs, and therefore our answer is 9 times 10 to the 5th newtons per coulomb. The book writes this as 0.9 times 10 to the 6th newtons over coulombs, which is equal to 0.9 times, not times, 0.9 meganewtons, which is the equivalent. So that, meganewtons per coulomb. So that's the answer to part B. Part B also expects us to find the angle. Since we know that F is equal to E times the charge, 2Q, we know that E in the x direction is equal to F, the x direction, over 2Q. Likewise, E in the y direction is equal to some F in the y direction over 2Q. Therefore, to find the angle at which the electric field exerts on particle 3, or if particle 3 was there, in this case it is not, then we would be using this inverse tangent of EY over EX. Getting that, plugging in these two formulas that we have above, we could end up with inverse tangent of some force in the y direction over some forces in the x direction, since the two q's will cancel each other out. And if you notice that this inverse tangent of Fy over Fx is exactly what we used before in part A, therefore we have the same angle as part A, 15.5 degrees. That's a 5, not a 6. Okay, and that is your answer for part B. So for part C, I asked, what's the E field at the center of the square? Okay, so here's the center there. Now we're going to draw in our forces. So our forces here are going to use the colors that it actually represents. particle 1 is going to exert a force, a repulsive force going diagonally downwards. Particle 3 is going to exert a repulsive force going diagonally upwards, but it's going to be stronger because it has a greater charge. Likewise, particle 2 is going to exert an attractive force upwards, kind of smaller error since it's a smaller charge. Particle 4 is going to exert a bigger attractive force downwards. Okay, so those are four electric fields exerting its presence on the center of the square. Now, to calculate the E field at this point, we're going to have to, again, use the X and Y components separately. So to do that, I'm going to say sum of the E fields in the X direction is equal to E1 is K times the charge of the particle 1, which is Q, over the distance. Since this is a square, the diagonal is a root 2, and therefore, and half that distance is a root 2 over 2. And that is also equal to a over root 2 squared. Okay, so a root 2 over 2 is equal to a over root 2. Okay, and you should know that. And since we're finding the X direction, we are taking cosine 45 because it is an angle of 45 degrees from the horizontal. Okay. Now, doing the same thing for force 2 is K. Absolute value of that charge is Q. Distance is also a root 2 squared cosine 45 degrees. Now we're going to add K. Electric field of particle 3 is charge 2Q. Distance is the same, squared. This is cosine negative 45 degrees. And then we're going to add the last one, K 2Q over a over root 2 squared cosine negative 45 degrees. Okay, and from here I'm going to factor out a KQ cosine 45 degrees, and cosine negative 45 degrees is the same thing as cosine 45 degrees. So I just skipped a step right there, but you can kind of figure out how I got that 2 in the numerator. It came from the fraction in the denominator. And you can just kind of figure that out with the algebra, even though I kind of skipped small calculations in the middle. Then going from there, we are going to simplify that a little bit, and we are going to get to your calculator, you will get 3.05 times 10 to the negative 6 coulombs to the right. And that is your answer to this problem. Okay, and you may be wondering, what about the y component? So if we go back and we look at this, problem, this is going to be almost exactly the same process as to finding the component in the y direction. We're going to sum up all our forces, but instead of using the x component, we're going to use the y component. Really, all that changes is cosine 45 degrees turns into sine 45 degrees, since we're finding a vertical component. Then if you look at this, this diagram that I've drawn with all the forces in it, let's see, I'm going to use another color here. Okay, so the charge or the electric field exerted by particle 2, Okay, so this electric field exerted by particle 2, this blue arrow right here, is counteracted by this particle 1's electric field, which is pointing perpendicular 45 degrees downwards, and they're both of the same magnitude since their charges are the same. Therefore, they would just cancel out. Same goes with the electric field exerted by particle 3, which is the bigger red arrow pointing upwards, and the electric field of particle 4, which is attracting it downwards at the same magnitude since they are both the same charge. So they would all just cancel each other out since they're all sine 45 degrees, and you would get 0 coulombs as a net E field in the y direction. If you don't believe me, you can just repeat all the steps and prove it mathematically, and you would find that I'm correct. It's just 0 coulombs. Therefore, your answer would just be the result of the electric field in the x direction, and as I've said, that is 3.05 times 10 to the negative 6 coulombs to the right.